Welcome to part B of forecasting. Quick reminder, if you landed directly on this video, I'd strongly suggest going back to part A first. In part A, we covered the fundamentals of forecasting, EAC, ETC, and the key formulas you need to know. Without that foundation, these examples may feel confusing. If you've already completed part A, excellent. Let's roll up our sleeves and apply these concepts with real-life examples. Let's start with a big tangible example, a bridge construction project. The total duration is 12 months and the planned cost is 10 million. But by the end of month 3.5, disaster strikes. One of the pillars collapses. Progress slows and the actual cost so far is 3.25 million. Now, this sets the stage. We have delays, unexpected costs, and a real-world scenario where forecasting becomes critical. Pause and think. If you were the project manager here, how would you estimate the final cost now? That's exactly what we are going to calculate in the next slides. When trouble is a one-time event, here's the first forecasting formula. EAC equals AC plus BAC minus EV. This is used when you believe the problem is a one-time event like our collapsed pillar. Once it's fixed, you assume the project will continue as originally planned. Let's calculate. BAC is 10M, AC is 3M, EV is 2M. Plugging in, EAC equals 3M plus 10M minus 2M equals 11M. So, the project will likely need 11 million instead of 10 million. Just 1 million over, because you're assuming that collapse was an exception, not the new normal. When problems become the new normal. Now, here's a more realistic scenario. What if problems keep happening? Then we use the formula EAC equals BAC upon CPI. Why? Because you're projecting future costs based on current cost performance. In our bridge project, by month 6, BAC is 10M, AC is 6M, EV is 4M, so only 40% done. CPI is EV upon AC, which is equal to 0.66. Now, EAC is 10M upon 0.66 equals 15.15M. Big difference, right? This shows if you keep spending at the same poor efficiency, the project will balloon to over 15 million. So, remember, EAC equals BAC upon CPI is for when poor performance is expected to continue. The double trouble. Cost and schedule both. Sometimes both cost efficiency and schedule delays matter. That's where this third formula comes in. EAC equals AC plus BAC minus EV upon CPI into SPI. In our bridge case, BAC was 10M, AC is 6M, EV is 4M, PV is 5M, CPI is 0.66, SPI is 0.8. Plugging in, EAC equals 6M plus 6M divided by 0.66 into 0.8 equals 17.36M. Ouch. This says if we continue at current cost and schedule performance, we'll need nearly 17.4 million. This formula is exam favorite. Why? Because it combines both efficiency measures, cost and schedule. Always look for SPI in the question. If it's given, they likely want this formula. Now let's test you with an exam-style question. You're presenting to the steering committee at the end of Q1 in a one-year project. Data is BAC equals 500K, SPI is 1.1, CPI is 1.05, EV is 1,73,000, AC is 1,64,761. Which EAC formula to use? Since it says progressing as planned, no major problems expected, that means use BAC upon CPI. So EAC equals 500,000 divided by 1.05, approximately 4,76,190. Answer is D. Remember, keywords like no major problems equals BAC upon CPI. Here's another exercise. CRM project with BAC equals 16,000. Some tasks are 100% done, others haven't started. Actual costs so far equal 3,400, EV equals 3,000. Formula to use? The question says, project will perform at budgeted rate going forward. That's the first formula. EAC equals AC plus BAC minus EV. So, EAC equals 3,400 plus 16,000 minus 3,000 equals 16,400. Answer is C. Did you notice the trick? They gave you both AC and EV separately. You had to calculate each before plugging into the formula. Not all projects can rely on formulas. Sometimes your estimates are fundamentally flawed, wrong from the beginning. In that case, you re-estimate. Formula is EAC equals AC plus new ETC. Example, a CRM project, BAC is 5M, you've already spent 1.1M. But after reassessment, your team says remaining design, development and testing will cost 5.5M. So, EAC equals 1.1M plus 5.5M equals 6.6M. Takeaway, if the question mentions fundamentally flawed estimates or revised estimates, use this re-estimation formula. How much more will it cost? Next is ETC or estimate to complete. Formula is ETC equals EAC minus AC, or simply re-estimate remaining work. Example, a house construction project, BAC is 1M, AC is 600K, EV is 400K, CPI is 0.66. First calculate EAC equals BAC upon CPI equals 1.52. Then ETC equals EAC minus AC equals 915K. So, the cost needed to finish the remaining work is 915,151. Remember, ETC answers how much more do we need to finish. Spot the keyword, pick the formula. Another exam style question. BAC is 5M, AC is 1.1M, EV is 1M. The question clearly says original estimates were flawed. This is a signal, use the re-estimation formula. So, EAC equals AC plus new ETC equals 1.1M plus 5.5M equals 6.6M. Answer C. Notice how examiners test you. They add small keywords like flawed estimates, continue with the same CPI, or no variances. Your job is to spot them quickly and pick the right formula. Will we finish under or over budget? Final concept, VAC or variance at completion. Formula is simple, VAC equals BAC minus EAC. If it's positive, the project is under budget. If it's negative, the project is over budget. Sometimes exam questions also ask for percentage. VAC percent equals EAC upon BAC. This metric tells your sponsor at a glance whether you're expected to finish under or over budget. Very practical for reporting. Alright, let's wrap up part B. We have now covered all the 4 EAC formulas, ETC and VAC with practical examples and exam-style exercises. Remember, in the exam, look for keywords. No variances equals BAC upon CPI. One-time event equals AC plus BAC minus EV. Flawed estimates equals AC plus re-estimate. Both cost and schedule impact equals AC plus BAC minus EV divided by CPI into SPI. Mastering this will give you a huge edge in PMP questions on forecasting. See you in the next session.